Okay, so the last thing we're going to do in this lecture is use our chart that we did on page 3, I believe it was, and might have been page 4, and we're going to answer some questions using the graph of f prime. So the first thing I'm going to do is I'm just going to recreate that chart that we did on one of the previous pages. Okay, so I know that if f is increasing or decreasing, then f prime is positive or negative. That information translates down a level, so increasing, decreasing, positive, negative, and by definition this means concave up and that means concave down. Okay, so part 1 of example 5, it says to find all critical points of f and classify them each as a local max, local min, or neither. Okay, well I know from the definition on page 2 that critical points come whenever the derivative f prime is equal to 0. And remember, back up there it says that we're given the graph of f prime, and so that's what we're looking at when we look at this graph. Okay, so if we look at all the places where f prime is equal to 0, that's going to be here, 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 and there. Okay, so we have 4 critical points, and I'm going to write those down sort of in a linear fashion so that I can write a sentence out next to them that describes what type of critical point they are, whether it's a max, a min, or neither. So we have x equals to -2, positive 2, 6, and 10. Okay, well at x equals to -2, what you should hopefully notice is that the derivative graph is changing from negative to positive. And so if I look back up at my chart, if f prime changes from negative to positive, that means that the original function changes from decreasing to increasing, which is going to create a minimum. Okay, so I'm going to write x equals to -2 is a local min, and then in order to justify my answer, I'm going to say because f prime changes from negative to positive. Now I have to be very specific here in saying f prime. It's not okay for me just to say it or the graph or even the given graph. We have to say f prime changes from negative to positive. I always want to make my argument based on what I am given. Okay, at x equals to 2, that's the next critical point, I see that there is no sign change in the derivative. The derivative is positive before 2 and then positive after 2, and so x equals to 2 is neither a max or a min, and I don't really need to say that part, I can just say neither, because f prime does not change signs. Okay, so that is the justification on why x equals to 2 is neither a max nor a min. Okay, at x equals to 6, I see the opposite happening of what I saw at x equals to -2. I see the derivative going from above the axis, or positive, to below the axis, or negative. So at x equals to 6 is going to be a local max because the derivative graph, f prime, changes from positive to negative. Okay, so that is a well-constructed sentence that correctly justifies my answer. Okay, and then at x equals to 10, I also see what was going on at x equals to 2. There is not a sign change in the derivative, so I'm going to say that x equals to 10 is neither because f prime does not change signs. Okay, so that completes number 1, so now we can move on to number 2. We want to find all intervals on which f is increasing or decreasing. Okay, so number 2 here, we want to say increasing, and we want to try to figure out when that's going to be. Well, if I look at my chart, f is going to be increasing whenever f prime is positive, and whenever I'm looking at a graph, positive just means above the x-axis. So positive would be all of this right here. Okay, so if I go down and write that, increasing, that would be from -2 to 6, and the justification is because f prime is positive. Okay, and then I want to say, when is f decreasing? Well, f is decreasing whenever f prime is negative, and that's what you can see right here from the chart. And so that's going to be here and also in those sections. Okay, so I'm going to write down from -4 to -2, and also from 6 to 12. And again, the justification is going to be since f prime is negative. Remember, you want to always argue through what you are given. We are given f prime, and so that's how I need to argue my stance on that particular part of the problem. Okay, number 3 is asking me about concavity. So find all intervals on which the graph of f is concave up or concave down. So I'm going to erase these colors here so that we can do that part. And so basically what we're wanting to see here is that if f is concave up, then that means that f prime is increasing. Okay, so where is f prime increasing? Well, that's, to put it simply, that's wherever the graph of f prime is going up. So that would be from -4 to 0 here, from 2 to 4 here, and then also from 8 to 10. Okay, and then where is the graph of f concave down? Well, that would be wherever the derivative is decreasing, and so that's going to be every other part here, which is from 0 to 2, and from 4 to 8, and from 10 to 12. Okay, so if we go down and write that, we are going to be concave up on -4 to 0, and also from 2 to 4, and then also from 8 to 10, and that's going to be because f prime is increasing. We're going to be concave down on all of the green parts up there, which would be from 0 to 2, and also from 4 to 8, and then finally from 10 to 12, and the justification there is because f prime is decreasing. And you can feel free to abbreviate increasing, decreasing, positive, negative, however much you want. Okay, scrolling back up to see what number 4 says. Number 4 is find all points of inflection of f. Well, if I go back to the other screen just real quick, we said right here that we find points of inflection whenever f changes concavity, f prime changes from increasing to decreasing, or when f double prime changes from positive to negative. So what I'm talking about are these 3 points right here. Well, the argument here is going to be through f prime. The reason for that is because that is what we are given. We are given the graph of f prime. So I'm going to need to try to figure out where is f prime going from increasing to decreasing, or vice versa. Okay, so that's going to happen right here at 4, or I'm sorry, at 0, because I want to do x values. So at 0, at 2, at 4, at 8, and also at 10. Okay, so 0, 2, 4, 8, and 10 are going to be my points of inflection. X equals to 0, 2, 4, 8, and 10. And the justification is since f prime changes from, I don't want to say positive to negative this time, I want to say increasing to decreasing, or vice versa. Okay, so hopefully these problems have helped you remember some things from pre-cal, and now you're able to tackle the assignment. Good luck to you guys. Let me know if you have any questions, and we'll talk to you on the next video.